Right, good day to each and every one of you. So for today's lecture video discussion is we will be discussing all about the introduction to radiation. So it is all about atomic physics and radiation. Okay, so to start our topic or our discussion, we will first discuss all about the atom. So when we define atom is the basic unit of matter. So it is the basic unit of matter, and then it is composed of the three main subatomic particles. So we call them as the protons, the neutrons, and also the electrons. So we will be discussing each of these main subatomic particles later. So that is the composition of our atom. Now here, as you can see on the figure, we haven't introduced yet what we call the nucleus. So what is a nucleus? So we will discuss this next. So when we say nucleus, so again going back to our figure, as you can see, the nucleus is located at the central part of the atom. So again, nucleus is the central part, or the location of the nucleus is at the central part of our atom. Now also, si nucleus contains protons and neutrons. So we have the green particle here, which we call the proton, and we have the red for the neutron. So also, can you see nucleus is extremely dense that makes up nearly all of the atom's mass. And also, the nucleus is positively charged due to the presence of the protons. So, we will again discuss later on kung anong positively charged man due to the presence of proton. So, unsa magidi ang charge ni proton. Okay, so now, this time is we will be discussing all about the three main subatomic particles of the atom, which is again the proton, we have the neutron, and also the electron. So let's start with the proton or protons. Now, si protons carry a positive charge. So that's why si neutron, as defined earlier, is or the nucleus, is positively charged due to the presence of protons because protons carry a positively charged or positive charge, which is +1. So also, they have a mass of approximately 1 atomic mass unit, or we also call it as AMU, which is about, if we will convert that into kilogram or kilograms, it is equivalent to 1.67 times 10 to the power of negative 27 kilogram. So that is the mass of the proton. And also, the location of our proton is obviously inside or are found inside the nucleus. So, what is the role of the proton? So now, the number of protons in the nucleus will determine the atomic number of an element. So again, we will be discussing later what is an atomic number, what is atomic mass, and so on. So the number of protons daw in the nucleus will determine the atomic number of an element, which defines the element itself. So if you're familiar with the periodic table, so each element on the periodic table has a unique number of elements. So for example, an atom with one proton is, again, so one proton meaning ang atomic number niya is 1, which is, kani siya nga element is the hydrogen. So also, while an atom with 6 protons, so if you will look at the periodic table, so atomic number 6 is si carbon. So carbon has 6 protons. Okay, so that is just an example. Now, we proceed with neutron or neutrons. So si neutron, what is the charge of neutron? So neutrons are electrically neutral, meaning they have no charge. So kung si proton is positive, si neutron is from the word neutral, meaning wala siya charge. It is neither positive nor negative. So, also, ang mass ni neutron is similar to that of a proton, which is again about 1 atomic mass unit or AMU. Now, how about the location of the neutron? So, by looking at our figure here, si neutron is located inside the nucleus alongside proton. So, again, neutrons and protons are found in the nucleus. And also, what is the role of a neutron? So the neutrons help stabilize the nucleus by offsetting the repulsive forces between positively charged protons. So the number of neutrons can vary within atoms of the same element, leading to different isotopes. So that is neutron. And now we will be talking about the third main subatomic particle, which is the electrons. So the electrons, again by looking at the figure, the electrons is located right here. So electrons are negatively charged particles, or they carry a negative charge or negative 1 na charge. Now, how about the mass of the electron? So, the electron have a very small mass compared to the protons and the neutrons. So, ang mass ni electron is approximately 1 over 183 of an AMU or of an atomic mass unit. So, gaan kaayo ni si electrons compared to the protons and the neutrons. So, how about the location? So as you can see, si proton and neutron are located inside the nucleus. Now, si electron is located in what we call the electron shells, or nasa sa electron orbits located si electron. So it orbits the nucleus in regions of space called the electron shells or the energy levels. So that is the location of our electron. Now, how about its role? Unsa may role ni electron sa atom? So, electrons are responsible for the chemical behavior of the atoms. So, the arrangement of the electrons in an atom's electron shells determines how it interacts and also bonds with the other atoms. So, also, electrons are involved in the formation of ions when atoms gain or lose them. So that is the role of the electrons. Okay, so now since we are done discussing all about the three main subatomic particles, which is again, or which are the proton, the neutron, and the electrons. So now we will be proceeding with the electron shells or the orbitals. So what are electron shells? So kani say orbitals, it is, di ba dira man nakabutang si electron, or dira nag orbit si electron. So the electrons are arranged in specific energy levels or shells around the nucleus. So if this is our nucleus, this is another perspective of what an atom. So specifically a carbon atom. So we have in the nucleus are the protons and the neutrons, and then on the shells or on the orbitals are the electrons. So the electrons now are arranged in specific energy levels or shells around the nucleus, and also these shells have different energy levels. So and electrons fill them in order of the increasing energy. So kaning outermost shell known as the valence shell. So it determines the atom's chemical properties and also its ability to form bonds. So to sum to sum it up sa atong topic for the atom, so the structure of the atom now consists of a dense positively charged nucleus that are made up of protons and also neutrons, and also it is surrounded by negatively charged electrons that orbit the nucleus in defined energy levels. So now the interactions between these particles determine the physical and the chemical properties of the atom. Okay. So, diba, we have discussed sa role na na-mention nato the atomic number, the mass number, and also the isotopes. So, we will be discussing that in the next slide. Okay. So, again, let's understand the concepts of the atomic number, the mass number, and also the isotopes. So these are essential to grasp the basic structure of atoms and also how they relate to the different elements. Okay, so let's start with atomic number. So the atomic number, we also call that as capital letter Z. So the atomic number, it is the number of protons in the nucleus of an atom. So again, naghatag tag example na if there is only one proton, so meaning ang atomic number is 1. So ang atomic number 1, if you will find that in the periodic table, it is hydrogen. So that is just an example. So again, the number of protons will determine the atomic number of an element. So it is a unique identifier for each element. So again, no two different elements can have the same atomic number. Kaya diba sa periodic table, each element have a specific nga atomic number. So walay pareha o atomic number nga element. Okay. So again, example, hydrogen has an atomic number of 1 because it has only one proton. So while carbon has an atomic number of 6 because it has 6 protons. So yes, this one right here, this is mo ni ang makita nato sa periodic table. So hydrogen, we have 1. This is the atomic number. Mo ni siya si atomic number. So it determines the number of protons. So meaning si hydrogen has 1 proton. And also si carbon, the atomic number of carbon is 6, which indicates na it has 6 protons. Okay. So the role of the atomic number determines the element's identity and also its position on the periodic table. So naka-plus-star na siya from 1 to how many elements are there? 100 plus. I can't memorize it, but each element has a position or specific position on the periodic table based on their atomic number. Okay. So for instance, so any atom with 6 protons is carbon. So regardless of the number of neutrons or electrons that it has. So magbase man ta sa number of protons. So dira nato hibalaan kung pila ka buok protons ang isa ka element, then that is its atomic number. Okay. Now let's proceed to the mass number. So we also call that as capital letter A. So kung si atomic number is Z, si mass number is A. So what is a mass number? So si mass number is the total number of protons and neutrons in an atom's nucleus. So if you want to find the mass number of an element, we have this formula. Mass number is equal to the number of protons plus the number of neutrons. So inanaon na to pagkahibalo ang mass number of an element. So, let's say for example, si carbon. So, si carbon atom has 6 protons and also it has 6 neutrons. So, if we want to get the mass number of carbon is we will add the number of protons and neutrons. So 6 plus 6 is equal to 12. So 12 is the mass number of carbon atom. Okay, so that is how we would get the mass number of an element. Now, the role of mass number, it gives the total mass of the nucleus and also it helps distinguish between different isotopes of the same element. So we will be discussing isotopes after this one. So may pasabot aning it helps distinguish between different isotopes of the same element. Now, let's discuss isotopes first para mahibal-an nato kung unsay pasabot aning role ni mass number. Okay, so what are isotopes? So now, isotopes are atoms of the same element that have the same atomic number. So, same atomic number daw, but different mass numbers. So, mo ni siya si isotopes. So, atoms of the same element daw that have the same atomic number pero different mass numbers due to the varying numbers of neutrons. So, the same daw sila, same element, the same atomic number, but lahi ang mass numbers. It's because of the varying numbers of the neutrons. Okay, so for example, si carbon. So carbon has several isotopes. We have carbon 12, carbon 13, and also carbon 14. So it means na si carbon 12 has, di ba, 6. 6 man ang atomic number ni carbon. So si carbon 12 has 6 protons and 6 neutrons. So 6 plus 6 is equal to 12. So that is the mass number of carbon 12. And also, si carbon 13 has again 6 protons and 7 neutrons. Okay, 6 plus 7 is 13. And for carbon 14, we have 6 protons and 8 neutrons. So that is, so despite the differences in the neutrons, so kani sila nga mga isotopes, all these isotopes are still carbon. So carbon ra gyapon ni sila because they have 6 protons. Nag-differ lang, nag-vary lang sa number of neutrons. So that is what we would call an isotope. So the same element, which is for example si carbon, but different lang ang iyang mass numbers. It's because again of the varying numbers of the neutrons. Now, the role of isotopes. So, isotopes can have different physical properties such as stability. So, some isotopes are stable while others are radioactive. Like, for example, si carbon 14. So, meaning they decay over time. So, that is the role of the isotopes. Now, how do we identify elements and isotopes? So let's apply ang atong na-learn about atomic number, mass number, and also the isotopes. So how can we identify elements and isotopes? Now, to identify an element, para mahibalaan ro nato ang element, you need to know its atomic number. So again, by looking at the atomic number, mo na siya ang naka-assign sa specific nga element. Now, for example, an atom with 8 protons is oxygen. So, regardless of how many neutrons or electrons it has. So, okay, since 8 protons man siya, so atomic number is 8. So, if you will look at, again, the periodic table, ang ika-8 na element is si oxygen. So, regardless of pila ka buok neutrons or electrons naa si oxygen, still, ang atomic number is 8 or it has 8 protons. So, How about identifying isotopes? Now, to identify a specific isotope of an element, you need both its atomic number and mass number. Kaya, di ba again, si mass number is equal to the number of the atomic number or the number of protons plus the number of neutrons. So, para may bala nato ang ma-identify nato ang specific isotope of an element, kailangan nato ang yung atomic number and also the mass number. So, for example, si oxygen 16 and also oxygen 18. So, we know that si oxygen has 8 protons, kaya ang iyang atomic number is 8 man. So, it has 8 protons. Both of them has 8 protons. So, kay oxygen 16, ang ato ang mass number is 16. So, 16 minus 8. So, meaning it has also 8 neutrons. So, si oxygen 16 has 8 protons and 8 neutrons. While si oxygen 18, so 18 minus 8 is 10. So, we have 8 protons and also 10 neutrons. So, both of these are isotopes of oxygen, but they differ on the number of neutrons and also their mass number. Okay. So now, let's proceed to electron configuration and also energy level. So, na-mention na nato sa ato ang di-discuss sa energy shell or sa electron shells or orbitals. So now, let's discuss further the electron configuration and also its energy levels. Okay. So for what is an electron configuration? So how would we define an electron configuration? So electron configuration, it describes how the electrons are arranged within an atom's orbitals. So which are again regions of space around the nucleus where electrons are likely to be found. So kani siya nga arrangement of the electrons across different energy levels or shells, and also we have what we call the subshells. So again, we will be discussing that later on, meaning shells and subshells. So it influences an atom's chemical properties and also the behavior of an atom. Okay. So let's talk about the shells and also subshells. So let's discuss first the shells or the energy levels. So we have here an example of an electron shell diagram. So we have here our nucleus, and these are the energy levels. So we have N equals 1, 2, 3, 4, 5. So that is the energy levels or the shells. So the electrons in an atom, kaya diba si electron tramanggid ang nag-orbit on the electron shells or orbitals. So electrons in an atom occupy specific energy levels or shells which are labeled as N equals 1, 2, 3, and so on. So here on this diagram, we have up to N equals 5. Okay, so now these shells, it represents increasing distances from the nucleus. So with N equals 1 being the closest, so here, si N equals 1 is ang pinakaduol sa nucleus, but it has the lowest energy level. So it means nga magkadako ang distance or magkadako ang atong N is magka-increase ang energy level kay magkalayo man siya. So the more nga layo ang ato ang shells is the higher the energy level. So each energy level can hold a certain maximum number of electrons. So it is determined by the formula 2n squared. So nakabutang po dere sa ato ang figure that the electron capacity is equal to 2n squared, where n is the electron shell number. So, mo ni si n equals 1, 2, 3, 4, 5. Okay, so for example, if n equals 1, so kani siya nga shell, si n equals 1, it can hold up to 2 electrons. Okay, from the formula 2n squared. So 2 times 1 squared is just equal to 2, where si n equals 2 can hold up to 8 electrons. So again, 2 times 2 squared, so 2 times 4 is 8. And then n equals 3, kani siya nga shell, si n equals 3, can hold up to 18 electrons. So, and so on. So, n equals 4 and also n equals 5. So, by using this, kani siya nga formula. So, that is how we would determine kung pila ka buok electrons ang pwede na ito ma-hold or pwede ma-hold sa isa ka shell. Pila ang ka electrons ang makaya sa isa ka shell. Okay. So, how about the subshells and the orbitals? So, si subshells, each energy level is divided into subshells. So, which are labeled as S, P, D, and also F. So, kani sila nga subshells, they contain orbitals, which are specific regions where the electrons are likely to be found. So, as you can see here on the figure, so si n equals 1, we call that as the K shell. So n equals 1 has one orbital. So kung S, the S subshell has one orbital. Si P subshell, so as you can see here, kani siya, mo ni siya ang mga subshells. So n equals 1, so si S ra, S nga subshell. So it has one orbital which can hold up to 2 electrons. Si n equals 2, it has two subshells. We have the S and the P nga subshells. So again, S subshell is makakater siya of 2 electrons, while si P subshell can hold up to 6 electrons. So that's why for n equals 2, ang ma-hold ani ni shell is 8 electrons. So from the formula nga 2n squared. And then for the n equals 3, it has 3 subshells. We have the S, P, and D. So the D subshell has 5 orbitals which can hold up to 10 electrons. Kani si D na subshell can hold up to 10 electrons, while si F na subshell can hold up to 14 electrons. So it has 7 orbitals, so makahold siya up to 14 electrons. So again, si S na subshell, S has 1 orbital. Si P subshell has 3 orbitals. We have the D subshell has 5 orbitals. And the F subshell has 7 orbitals. Okay. So, muna ang iya ang it can hold up to, so times 2 lang dayon for each orbital. So muna ang number of electrons nga ma-hold sa kada subshell. So sa S subshell, it can hold up to 2 electrons. Si P subshell can hold up to 6 electrons. Si D subshell can hold up to 10 electrons, and also si F subshell can hold up to 14 electrons. Okay. So, example of subshells. Now, for n equals 2, the energy level has 2 subshells. We have 2s and 2p. So, 2s holds 2 electrons, while 2p holds 6 electrons. So for a total of 8 electrons in the second energy level. So naadari sa ato ang figure. So si S can hold 2 electrons, while si P can hold up to 6 electrons, so a total of 8 electrons on the N equals 2 or the second energy level. Okay, so as for the electron configuration notation, so electron configurations are written using a notation that shows the distribution of electrons among the energy levels and also subshells. So the general format is 1s2, 2s2, 2p6, where the number indicates the energy level. So kaning number nga 1, 2, 2, this indicates the energy level. The letter represents the subshell, katong S, P, D, and F. And the superscript is kani sila. The superscript indicates the number of electrons in that subshell. So that is how we would write a notation for the electron configuration. So example nato is carbon. So carbon has an atomic number of 6. So ang iyang electron configuration is we have 1s2, 2s2, and 2p2. So this means nga ang naa sa s orbital or ang naa sa n equals 1 nga energy level is si s orbital, which has 2 electrons. And then we have naa sa atong s orbit sa second na energy level, we have the s and the p subshells. So on the s subshell, as s orbital or s subshell, we have 2 electrons, and also on the p nga orbital we have 2 electrons, so a total of 6. So that's why the atomic number of carbon is, so ang total number of electrons is 6. Okay. So we are done discussing all about the atoms. We have the electron configuration. We also have the shells and the subshells, the atomic number, the mass number, and the isotopes. Now we will now be discussing all about radiation. So since our topic is all about the introduction to radiation, so let's talk about radiation. Now, radiation is energy emitted. So energy emitted in the form of waves or particles. And it occurs naturally in the environment from various sources. So we have here on this figure, we have, actually not all of this are naturally, or it occurs naturally. Some of this are man-made. But we have these natural sources of radiation. So these natural sources of radiation contribute to what is known as the background radiation, which is present everywhere on Earth. So now understanding these sources is very important for assessing their impact on also the human health and the environment. So natay mga here we will be discussing four natural sources of radiation. So when we say natural sources, it is not man-made. So it occurs naturally in the environment. So let's talk about the first one, which is what we call the cosmic rays. So we have here an example of what is known as a cosmic ray or cosmic rays. So cosmic rays are high energy. So the origin of cosmic rays are, they are high energy particles that originate from outer space. So they came from outer space, including the sun and also the distant stars. So now when this particle enter the Earth's atmosphere, now they interact with atmospheric molecules. So which creates secondary radiation that reaches the Earth's surface. Now, what is this type? Unsa man ni siya nga type of radiation, si cosmic ray or cosmic rays. So now cosmic rays primarily consist of protons and other atomic nuclei. So they produce again secondary particles, including the muons, the electrons, and neutrons, which contribute to again what we call the background radiation. So, unsa may significance ani ni cosmic rays? So, the intensity of cosmic radiation increases with altitude and latitude, meaning the people living at higher elevations or closer sa poles receive higher doses of cosmic radiation. So, for example, airline pilots and also astronauts are exposed to higher levels of cosmic radiation. Again, the intensity of cosmic radiation increases with altitude and latitude. So, the pilots or the airline pilots and astronauts are exposed to higher levels of cosmic rays rather than those nga na lang sa sea level lang. So, while cosmic rays also are a significant source of natural radiation, so the doses nga ma-receive sa mga tao are generally low and also it is not harmful. So, safe ra ni say cosmic rays nga type of radiation. Okay, so that is the first one na natural source of radiation. So, cosmic rays. Now, let's go proceed to number 2. So, ang atong number 2 is si radon gas. So, what is the origin of radon gas? Now, radon gas or radon is a radioactive gas that forms naturally from the decay of uranium and thorium in the Earth's crust. So, gikan gid siya sa pinakailalom gid or sa crust sa Earth. So, it is colorless, odorless, and tasteless. So, it makes us very difficult to detect. Now, kung wala tayo specialized na equipment, so dili na to siya ma-detect because it's colorless, odorless, and also tasteless. So, kani si radon gas, it can seep into buildings or houses through the cracks in the floors, the walls, and also the foundations of the building or the house. So, that is one way nga makasulod sila or makasip sila into the houses or the buildings. Now, unsa man nga type of radiation si radon? Now, radon and its decay products, it emits alpha particles which are form of ionizing radiation. So, si radon is the most significant source of natural radiation exposure for most people. So, but prolong kung exposed kay ka to higher levels of radon, now especially in poorly ventilated indoor spaces, and then naaday mga cracks or sa mga floors, sa walls, or sa foundations, so it increases the risk of lung cancer. So, lisod kay siya i-detect if we don't have any specialized equipment, kay it is again odorless, colorless, and also tasteless. So, now radon is the second leading cause of lung cancer after smoking. So, smoking magid ang first na leading cause of lung cancer. So, the second cause is si radon nga gas. So, testing for kung mapatest kag radon and mitigating its presence in homes and buildings is important for reducing health risks. Okay. So, That is the second natural source of radiation. So again, the first one, we have the cosmic rays. The second one is the radon gas. And then the third one is what we call the terrestrial radiation. So what is a terrestrial radiation? So what is the origin of terrestrial radiation? So terrestrial radiation comes naturally occurring radioactive materials in the Earth's crust, such as we have uranium, thorium, and also we have potassium 40. Now, kani sila nga mga elements are found in soil, we have rocks, and also water. So, dira nato na makita dira nato na sila makuha ng mga elements. Okay. Now, unsa man nga type of radiation si terrestrial radiation? Now, terrestrial sources primarily emit gamma rays. So, kung si radon, it emits alpha particles. Si terrestrial, it emits gamma rays, along with some alpha and beta particles. So, kaning level of terrestrial radiation, it varies depending on the local geology. So, the areas, na mga areas with high concentrations of uranium or thorium in the soil or rocks may have higher levels of background radiation or terrestrial radiation. So, kaning mga people that are exposed to terrestrial radiation, so both outdoors and also indoors, as natin mga building materials such as brick, concrete, and stone can also contain radioactive elements. Now, however, for most people, the exposure levels are low and also it is not a significant na health concern. So, safe ra gyapon ni siya si terrestrial radiation. Now, we have also the fourth one, which is what we call the internal radiation. So, kani si internal radiation, ang origin ani, or where can we find an internal radiation? So, internal radiation comes from radioactive elements that are naturally present inside the human body. So, this include isotopes like carbon 14, we have potassium 40, and also radium 226, which are taken in through food, water, and air. So, that is what we mean by internal radiation. And also, this type of radiation involves low-level emission of beta particles and also gamma rays. So, although si internal radiation is present throughout our lives, now the levels are very low and also it do not pose a significant na health risk under normal circumstances. Now, since we are done mentioning the natural types of or sources of radiation, now we will talk about the artificial or dali na po ito sa artificial or man-made sources of radiation. So, artificial or man-made, also known as man-made sources of radiation. So, this radiation, so here are some examples of artificial sources of radiation or man-made sources of radiation. So, these sources of radiation are those created or controlled by human activities. So, these sources are widely used in various fields, including medicine, we have the energy production, and also the industry. So, understanding these sources is important para ma-appreciate nato ang ilang benefits as well as for managing the associated risk. So, as for the artificial sources of radiation, we will be mentioning four sources or four artificial sources of radiation. So, let's start with the first one, which is very common. We have the medical X-rays. So, the origin for this one, or for this radiation. So medical x-rays are produced by x-ray machines. So I think most of us, or all of us, may have encountered x-ray machines. So which is kasagara is we need that as a, if magpa physical exam, yes, physical exam, or if you have a broken bone, baka so we need x-ray machine, we need an x-ray para makita nato kung asa dapit ang fracture and so on. So can I see medical x-rays are produced by x-ray machines which generate high energy electromagnetic waves that can penetrate the body to produce images of internal structures. So here are some examples of an x-ray na result. So makita ang internal structures of the body. Now, this type of radiation, can you say x-rays, are form of ionizing radiation, which means that they have enough energy to remove tightly bound electrons from atoms, which potentially causing cellular damage. Now, okay, so what are the applications of medical x-rays? So there's some applications. We have, di ba, gamit kayo sa x-ray in medicine to diagnose and also monitor various conditions such as, again, fractures, infections, and also tumors. So like CT scan. So CT scans also use x-rays to create detailed cross-sectional images of the body. Now, it provides more information than the standard x-rays. And also, napod tayo ginatawag nga radiation therapy. So, radiation therapy are x-rays that are used in higher doses for radiation therapy to treat also cancer by targeting and destroying cancerous cells. So, kanisi medical x-rays are invaluable tools for diagnosing and also treating diseases, but they must be used carefully to minimize exposure to healthy tissue. So, I don't know if nakikita ba ninyo sa mga hospitals that they have protective measures such as lead shields, and also naiginasuot ang mga technicians, ang mga rad techs na suit to protect themselves from this x-ray. So they are often used to reduce unnecessary radiation exposure. So those are the applications of medical x-rays as well as the significance of medical x-rays. Now let's proceed to the second one. Second one is the nuclear reactor. So we have here a figure of how a nuclear reactor would function and how it reaches the houses, the buildings, and so on. So nuclear reactors produce radiation through the process of nuclear fission, where heavy atomic nuclei such as uranium-235 and also plutonium-239 split into smaller nuclei and releasing energy in the form of radiation. So this type of radiation, the nuclear reactors emit various forms of ionizing radiation, including the gamma rays, we have the neutrons, and also the beta particles. So what are the applications sa nuclear reactors? So wala man tay, I think as of now, we don't have any nuclear reactors here in the Philippines, but there are some countries nga naa sila nuclear reactors. So, ang applications for the nuclear reactors, we have electricity generation. So, nuclear reactors are used to generate electricity in nuclear power plants. So, we have the heat nga ma-produce by nuclear fission is used to produce steam, which drives turbines connected to generators, which produces electricity. And also, another application is the research reactors, and also we have nuclear propulsion. So, kani si nuclear propulsion, so nuclear reactors are also used for power submarines and also aircraft carriers, providing a long-lasting energy source without the need for frequent nga refueling. So, kanay si nuclear reactors, ang significance gid ani niya, so it plays a crucial role in energy production. So, mostly si nuclear reactor is, ang iyang role gid is on the energy production. So, providing like a low carbon alternative to fossil fuels. However, they also pose significant risk such as radiation leaks and also nuclear accidents. So, as you can see, if I don't know if you're familiar with the nuclear reactor sa Japan, nga wala na nag-function as of now. So, because of the nuclear nga accident sa ilang nuclear reactors, so there are radiation leaks. So, naipart gid ana nga duol sa nuclear reactor nga wala na ginapuy anong tao. It's because of the significant nga risk or exposure to higher exposure to radiation. So, which requires strict safety measures and also waste management protocols. So, that is for our second artificial source of radiation. Now, let's talk about the third one, which is the industrial radiography. So, the industrial radiography uses radiation to inspect the integrity of materials and structures, such as we have the pipelines, we have the welds, and also the machinery. So, ginagamit ni siya. So, radioactive isotopes, such as cobalt-60 or iridium-192, or even X-ray machines, are commonly used for kaninga purpose. Okay. As for the type of radiation, kani si industrial radiography, ang iyang primary form of radiation is we have the gamma rays and the X-rays nga ginagamit for the industrial radiography. Now, ang applications or some of the applications of industrial radiography are we have the non-destructive testing, we have the quality control, and also security screening. So, if kani po si radiography is used in security applications, such as kaning mag-scan og mga luggage and cargo for contraband and also explosives. So, kani si industrial radiography is essential for maintaining safety and also reliability and critical infrastructure and also manufacturing processes. So, however, it requires careful handling and also shielding to protect workers. Kay exposed man gyapon sila sa radiation ang mga workers. So, dapat there must be careful handling and shielding para ma-protect ang mga workers nga gagamit ani nga mga materials or ani nga mga aning industrial nga radiography from radiation exposure. Okay, so aside from this three nga artificial or man-made na source of radiation, we also have other artificial sources. So we have the nuclear weapons testing. So si nuclear weapons testing, it involves the detonation of nuclear devices which releases large amounts of radiation into the environment. So, um, there are countries, let's say for example sa USA, na sila nuclear weapons testing, but ilan ang buhaton sa kanang walay nagpuyo nga lugar. So pero as of now, the nuclear weapons testing has largely ceased. So the residual nga radiation from the past ng mga tests, it continues to contribute to global background radiation levels gihapon. So okay, kani siya nga type of radiation. So kaning testing or nuclear weapons testing, it produces gamma rays, neutrons, and also radioactive fallout containing various isotopes such as cesium-137 and also strontium-90. Now, that is other artificial source. First nga, other artificial source. And then we have the second one, which is the consumer products. So, naapoday ni radiation, kani sila nga mga products. So, some consumer products contains small amounts lang di ay, small amounts of radioactive materials, such as we have smoke detectors. So, si smoke detector, wata kabalo, naadi na sila small amounts of radioactive materials. So, which uses, si smoke detectors uses americium-241 and also some luminous watches. Di ba makakita tayo sa na yung mga watches nga if ma-expose sa ngit-ngit is mo na siya musiga siya. So it uses tritium and also radium. But again, these consumer products or kani sila nga mga products contain small amounts of radioactive nga materials. So again, the radiation levels from these products are generally very low and also not harmful under normal use. So because these products emits alpha and beta particles or low-level gamma lang nga radiation. But again, they still contribute to the overall nga radiation exposure. Okay, so since we are done discussing all about the natural and also artificial sources of radiation, now let's talk about the electromagnetic spectrum. Now, what is an electromagnetic spectrum? So, electromagnetic spectrum is the range of all types of electromagnetic radiation, which are waves of energy that travel through space at the speed of light. So, kani siya nga spectrum is crucial for understanding various natural phenomena. We have technological applications and also forms of energy. So, there are different types of electromagnetic radiation. So, these types of electromagnetic radiation vary in wavelength, in frequency, and also energy, as well as they have different properties and also uses. So, before we proceed with types of electromagnetic radiation, now let's define first what are wavelength, frequency, and also energy. So, si wavelength, it is the distance between successive peaks of a wave, typically measured in terms of meters. So, si wavelength is the distance from peak to peak. So, when we say peak, muna siya ang pinakataas sa nga part sa wave. So, from the first peak, let's say for the first peak to the second peak, kada siya nga distance is what we call the wavelength. So, how about frequency? Now, frequency is the number of wave cycles that pass a given point per second, and it is measured in hertz. So, I don't know if you know this, but 1 hertz is equivalent to 1 over second. So, number of wave cycles per second man. So, 1 hertz is equivalent to 1 over second. So, that is hertz. And then we have energy. So, the energy of the electromagnetic waves is directly proportional to their frequency. And inversely proportional to the wavelength. So again, ang energy sa atong electromagnetic waves is directly proportional sa frequency, and it is inversely proportional to their wavelength. So meaning, higher nga frequency waves have higher energy. Okay. So now, let's talk about the types of electromagnetic radiation. So, the electromagnetic spectrum is divided into several regions based on its wavelength and also its frequency. So, kani sila nga types of electromagnetic radiation is listed from the longest to the shortest wavelength or lowest to highest na frequency. So, the first one is what we call the radio waves. So, ang wavelength ni radio waves is greater than 10 centimeters or up, pwede po siya up to kilometers. Basta kay greater than 10 centimeters. So, and also its frequency is less than 3 gigahertz. And also, what are the uses of radio waves? So, the uses are radio and television nga broadcasting. We have the wireless communication, we have the cell phones, we have the Wi-Fi. So, wireless communication, we have the radar, and also satellite transmissions. So, the significance of radio waves, these are crucial for communication technologies. So, gamit ka ini sa radio waves to transmit signals over long distances. So, these are radio waves. Now, let's proceed to the second one. So, second one is what we call the microwaves. So, si microwaves, as for the wavelength, it is from 1 millimeter to 10 centimeter. 10 centimeters ay ang wavelength. Now, for the frequency, we have from 3 gigahertz to 300 gigahertz. And also the uses for microwaves is what we commonly call the microwave ovens. So I think all of us are very familiar with that. We have the wireless communication, which is we have the Bluetooth and the Wi-Fi, and also radar systems. So the microwaves are also widely used in cooking and communication. So also in telecommunications, they are essential for transmitting data and signals over short distances. So that is microwave or microwaves. Now let's proceed to the third one. The third one is what we call the infrared or the IR radiation. So si infrared, ang wavelength is from 700 nanometers to 1 millimeter. Its frequency is from 300 gigahertz to 430 terahertz. And the uses of infrared or ang commonly nga uses sa infrared radiation is the thermal imaging. We have the night vision, and also we have the remote controls and heating. So those are some of the uses of infrared radiation. So it is emitted by warm objects, making it useful for detecting heat signatures. So it is also used in various nga remote sensing and also communication nga technologies. So that is infrared radiation. Now for the fourth one, we have the visible light. So kani si visible light is the only part of the electromagnetic spectrum that can be seen by the human eye. So it is crucial for vision, art, and so many practical applications such as lighting. So as for the visible light, ang wavelength niya is from 409 nanometers to 700 nanometers. Its frequency is from 430 terahertz to 730 terahertz. And again, the uses are, we have the human vision, photography, and also illumination. So that is the visible light. Next is the ultraviolet or UV radiation. So, as for UV radiation or ultraviolet, ang wavelength niya is from 10 nanometers to 400 nanometers. Its frequency is from 700 terahertz to 30 petahertz. And the uses for the UV or some, not all, kay daghan mo kay uses si ultraviolet. Some of the uses are sterilization, we have the tanning, and detecting counterfeit money. So gamit kina siya if sa mga banks kaning para i-check nila kung dili ba fake ang ato ang kwarta or dili. So the UV radiation has higher energy now than the visible light. So it allows also to kill bacteria and also viruses. So again, it's because isa sa iyang mga uses is sterilization. However, excessive nga exposure can damage living tissues. So it also leads to skin cancer and other nga health issues. So that is the ultraviolet or UV radiation. Now let's proceed to the sixth one. We have the X-rays. So si X-ray, ang wavelength niya is from 0.01 nanometer to 10 nanometers. Its frequency is from 30 petahertz to 30 exahertz. And the uses of X-rays are medical imaging, security screening, and also material analysis. So the X-rays have like high energy and also can penetrate most materials, now making them invaluable for medical diagnostics and also security purposes. So however, again, they can also be harmful. So dapat ang exposure must be carefully controlled. So that those are X-rays. And then we have the last one, which is what we call the gamma rays. So si gamma rays, ang iyang wavelength is less than 0.01 nanometer. The frequency is greater than 30 exahertz. And some of the uses of gamma rays are cancer treatment, which is again the radiation therapy. We also have sterilization and studying atomic and also nuclear processes. So the gamma rays have the highest energy and can penetrate deeply into the materials. So they are used in medicine for cancer treatment and also in scientific research to study high energy nga processes. So gamma rays are also produced in nuclear reactions and can also be harmful in high doses. So the electromagnetic spectrum encompasses all the types of electromagnetic radiation, from low frequency radio waves up to the high frequency nga gamma rays. So each type of radiation has its unique properties and also applications. So as you can see earlier from the previous slides, so each nga spectrum lagi siya unique nga properties and applications. So ranging from the communication, the cooking, to medical imaging and also cancer treatment. So understanding the electromagnetic na spectrum is crucial for advancing technology, protecting health, and also exploring the natural world. Okay. Now, let's focus more on X-rays and gamma rays. So, nganong ato maning i-focus ni si X-rays and gamma rays? Now, X-rays and gamma rays occupy the high energy end na sa atong electromagnetic spectrum. So, these are the last nga two types of electromagnetic spectrum. So, ang ilang placement within the spectrum is characterized by short wavelengths, high frequencies, and high energy levels. So understanding their relationship or the relationship of these two uh, spectrums in terms of energy, wavelength, and frequency will help us to explain ang ilang unique nga properties and applications. Now, let's review again kaning duha, si X-ray and si gamma rays. Now, as for the X-rays, it is located between the UV radiation and gamma rays on the spectrum. And again, ang wavelength ranges from about 0.01 nanometer to 10 nanometers. Ang frequency niya ranges from 30 petahertz to 30 exahertz. And its energy typically ranges from about 100 electron volts to 100 kilo electron volts. Whereas, for the gamma rays are located at the extreme high energy end of the spectrum. So, pinaka-last siya. As you can see on the previous slide, pinaka-last siya sa type of electromagnetic spectrum. So, the wavelength is less than 0.01 nanometer. So, often in the picometer range or even smaller. Ang frequency niya is greater than 30 exahertz. And ang iyang energy typically starts at around 100 kilo electron volts and can go up to several mega electron volts or even giga electron volts in some cases. Now, let's talk about, again, na-mention nato, we need to understand the relationship in terms of energy, wavelength, and also frequency para ma-explain nato ang ilang unique properties and also applications. Now, let's talk about the energy, wavelength, and frequency relationships. So, these relationships between energy, wavelength, and frequency in the electromagnetic spectrum are also governed by the following fundamental nga equations. Now, as for frequency and wavelength nga relationship, we have this formula C is equal to F times lambda, where ang atong C is the speed of light, so it is equal to 3 times 10 to the power of positive 8 meters per second, so in a vacuum. F is the frequency of the wave, and we have lambda is our wavelength. So that is for the frequency and wavelength nga relationship. While for the energy and frequency relationship, we can use this formula E is equal to H times F. So E is the energy of the photon. So we can have it in terms of joules or electron volts. H is our Planck's constant, which is equivalent to 6.626 times 10 to the power of negative 34 joules seconds. And our F is our frequency. Now, given this relationship, if you can, as you can see on the formula or equations, so given now this relationship, the higher the frequency or higher frequency corresponds to shorter wavelength and higher energy. Now, if manotice nato si X-ray and gamma rays, they are sila have some of the shortest wavelengths and highest frequency on the electromagnetic spectrum. So, as you can see here, which means they also have very high energy. So, magtanaw pa lang ta sa ilang energy levels nila is dagko jud. Okay. Now, what are the differences between X-rays and gamma rays? Now, as for the source of this spectrum, X-rays are typically produced by high energy electron transitions in atoms or by decelerating charged particles, whereas si gamma rays are produced by nuclear reactions such as radioactive decay, we have nuclear fusion and fission, or by processes in astrophysical environments. So, mo na ilang differences as for their source. Okay, but how about their energy levels? Now, while there is like some overlap, as you can see, gamma rays generally have higher energy than X-rays. Diba? Sa katupalang daan na previous na slides, as you can see, si gamma rays have higher energy than the X-rays. So, for example, ang medical nga X-rays typically range from, let's say, a few kilo electron volts up to 100 electron volts, while ang gamma rays, let's say from the radioactive nga decay, often kasagaran mo exceed siya 2 mega electron nga volts. So si X-rays lang is ang iyang energy is in kilo electron volts, whereas si gamma rays ang iyang energy is maabot pa into mega electron or even giga electron nga volts. Okay, so those are the differences between X-rays and also gamma rays. So X-rays and gamma rays are located again on the higher end or high energy end of the electromagnetic spectrum. So they have short wavelengths, high frequencies, and also high energies. So we have seen the applications of X-rays, which are used in medical imaging and also in industry, while gamma rays are used in medical treatment and research, which originates from nuclear reactions. So those are the differences between X-rays and gamma rays. Okay, so here, now the field of atomic physics has been shaped by several key discoveries, which have revolutionized our understanding of the atom and laid also the foundation for the modern science. So two of the most important contributions or the discoveries in atomic physics, we have two of the most important contributions we will be discussing here are Rutherford's gold foil experiment and also the Bohr's atomic model. So here are the summary of these discoveries and also the impact of these discoveries in atomic physics. Okay, so let's start with Rutherford's gold foil experiment. So it happens on 1909. So the experiment, so this is a sample of the gold foil experiment of Rutherford's. So this experiment obviously was conducted by Ernest Rutherford and his team. So this gold foil experiment now involved directing a beam of alpha particles, which is a helium nuclei, at a thin sheet of gold foil. Now, most of the particles passed through the foil, but there are some nga ni-deflect at large angles, and there are even a few who bounce back. So, through this experiment led to the discovery of the nucleus. So again, nucleus is the center or located at the center of the atom. So nucleus is a small, dense, positively charged core at the center of the atom. So si Rutherford proposed nga the atom is mostly empty space with electrons orbiting around the central nucleus. So the impact of Rutherford's experiment overturned the earlier what we call the plum pudding model that is proposed by J.J. Thomson. So, which kaning plum pudding model suggested that the atom was a uniform sphere of positive charge with embedded electrons. So again, it established the nuclear model through this experiment. It established the nuclear model of the atom, which is now the fundamental to our understanding of the atomic structure. So this discovery laid the groundwork na dayon for further research into the nature of the nucleus and also the forces that hold it together, which eventually leading to the development of nuclear physics and also quantum mechanics. So that is one out of the two of the most important contributions sa atomic physics. Now, the second one is what we call the Bohr's atomic model. So, it was proposed at 1913. So, this is an example of Bohr's model of an atom. So, again, it is proposed by Niels Bohr. So, this model refined Rutherford's nuclear model by introducing the concept of quantized energy levels for electrons. So, according to Bohr, the electrons orbit the nucleus in specific discrete orbits and can only gain or lose energy by jumping between these orbits, so which we call as the quantum leaps. So, kani siya nga discovery. So, Bohr's model explained the stability of the atoms and also the discrete spectral lines observed in atomic emission and absorption spectra. So, specifically, it describes the hydrogen atom's spectrum by linking electron transitions between energy levels to the emission or absorption of light at specific wavelengths. So, ang Bohr's atomic model, this was a very major step forward in the development of quantum theory. So, kani siya nga concept. His concept of quantized energy levels remains central to atomic physics. So, kani siya nga model help bridge classical physics and also quantum mechanics, influencing the development of quantum theory, atomic and molecular physics, and also modern chemistry. Okay, now let's talk about the significant milestones in radiation physics. So, we have the discovery of X-rays and also radioactivity. So, these discoveries of the X-rays and radioactivity are among the most significant milestones in radiation physics. So, these discoveries not only advance our understanding of atomic and also subatomic processes, but it also led to the groundbreaking developments in medicine and industry and also in the scientific research. So, let's talk about the discoveries of the X-rays and radioactivity. So, as for the discoveries of X-rays, it was discovered on 1895. So, who discovered this one? So, it was discovered by Wilhelm Conrad Röntgen, which is a German physicist. So, now while experimenting with cathode rays, or what we call the streams of electrons in a vacuum tube, now si Röntgen, I don't know the correct pronunciation of this one, noticed that a fluorescent screen in his lab began to glow. So even though it was not on the direct path of the cathode rays. So he also created, he realized na there was an unknown type of radiation that was being emitted from the tube. So which could pass through solid materials like paper and flesh, but was blocked with by denser substances like bone and metal. So, na-discover na niya discovered ang X-rays, which is, again, a form of high-energy electromagnetic radiation. Now, he also created his first X-ray image. So, famously showing the bones in his wife's hand. So, here is the original X-ray image sa iya ang wife's hand. So, that is the first nga X-ray nga image nga na-create ni Röntgen. So, Again, the significance of X-rays. We have the medical imaging. We also have a scientific research and also in industrial application. So, na-mention na late the previous discussions all about X-rays. Now, how about the discovery of radioactivity? So, okay, so here are the significance of X-rays. So, nadara ang medical imaging, scientific research, and industrial applications. Now, let's talk about the discovery of radioactivity. So, kung si X-ray na-discover siya on 1895, si radioactivity was discovered on 1896. So, who discovered radioactivity? So, it is discovered by Henry Becquerel, which is a French physicist. So, this is a photo of Henry Becquerel. So, si Henry Becquerel was studying phosphorescent materials that glowed after exposure to light. So, he accidentally discovered that uranium salts emitted radiation that could expose photographic plates even without exposure to sunlight. Kaya ang iyang gistudihan naman is mga phosphorescent materials nga mo glow after exposure to light. But here, na-discover niya nga ang uranium salts di ay will emit radiation nga maka-expose sa photographic plates even without the exposure of sunlight. So, this emission of radiation was spontaneous and did not require an external energy source. Okay, so the radioactivity, the niya discovers radioactivity, which is the spontaneous emission of radiation from certain elements. Now, what are the significance of radioactivity? So, the first one is the fundamental understanding. So, ang discovery sa radioactivity, it provides key insights to the structure of the atom, suggesting that atoms were not indivisible as previously thought, but had internal components that could undergo changes. So, that is the first nga significance sa discovery sa radioactivity. The second one is the birth of nuclear physics. So, radioactivity led now to the development of nuclear physics, including the study of nuclear reactions, radioactive decay, and also the strong nuclear force. And then the third na significance is the medical and industrial applications. So, ang radioactive nga isotopes are used in medicine for, again, diagnostics and treatment. So, which is, for example, in cancer therapy, as well as also in industrial applications like radiography, power generation, and also environmental tracing. So, those are the significance of the discovery of radioactivity. Now, there are also further contributions to radioactivity. So, dili lang kay si Henry Becquerel lang. So, naapagi mga further contributions after Becquerel discovered radioactivity. So, ang further contributions to radioactivity is si Marie and Pierre Curie. So, they discovered, or they have their further contributions to radioactivity on 1898. So, this couple, or the Curies, as we call them, expanded Becquerel's work by discovering two new radioactive elements, which are the polonium and also the radium. So, what we did is they isolated these elements from uranium ores and also studied their intense radioactivity. So, the discovery of radium and polonium confirmed that radioactivity was a property of certain elements, and dili lang kay uranium lang. So, the Curie's work, or this couple's work, laid the foundation for the field of radiochemistry. and further the understanding of radioactive decay. So kani si radium na dayon became an important tool in cancer treatment, so which is known as the radium therapy, and was also used in luminescent paints. So although its hazards were later nga recognized na siya nga na siya mga hazards. Okay, so aside from the Curies, we also have si Ernest Rutherford. So from 1899 to 1902, so si Rutherford identified and classified different types of radiation emitted by radioactive materials, now coining the terms alpha, beta, and gamma rays. So this is a photo of Ernest Rutherford, and also he discovered the concept of half-life and proposed that radioactivity involved the transmutation of elements. So Rutherford's work on radioactivity helped establish the modern understanding of nuclear reactions and decay processes, as well as the identification of isotopes. So his research, ang research ni Rutherford, contributed to the eventual development of nuclear energy and atomic nga weapons. So those are the further contributions after nga na-discover ni Becquerel ang radioactivity. Now, let's discuss the milestones, or let's discuss the milestones in radiation physics. So what are the milestones? So ang milestones niya, first is the first use of X-rays in medicine. So di ba, na-discover si X-rays on 1895. So na-discover siya ni Röntgen, and the first use of X-rays in medicine is on 1896. So the X-rays were quickly adopted for medical diagnostics after the discovery. So ang first nga recorded medical use was in 1896, just a year after Röntgen's discovery, where when X-rays were used to locate a bullet in a patient. So muna siya ang first, ang milestone sa radiation physics, which is the first use of X-rays in medicine. Now, the second milestone is the discovery of artificial radioactivity, which is on 1934. So it is discovered by Irene and Frederick. I don't know how to pronounce this one. I think it's Joliot-Curie. So they discovered that certain stable elements could be made radioactive by bombarding them with alpha particles, leading to the creation of artificial radioactivity. So this discovery opened the door to the production now of radioactive isotopes for the medical and industrial use na dayon. And it was a precursor to the development of nuclear reactors. So that is the second milestone. And then we have the third milestone, which is the development of the Manhattan Project in the 1940s. So the study now of the radioactivity and also the nuclear reactions during the early 20th century now led to the development now of the nuclear weapons. So during World War II, which culminates in the creation of the atomic bomb. So kani po siya nga project, the Manhattan Project, also led to advancements in nuclear energy and also the establishment of nuclear physics as a major nga scientific nga discipline. So the discovery of X-rays by Wilhelm Röntgen and also the radioactivity by Henry Becquerel were the pivotal moments in the history of radiation nga physics. So kani sila nga mga milestones revolutionized science and technology that leads to the development of like medical imaging. We have the cancer treatments, nuclear energy, and many other applications. So, kato pong mga further nga contributions nilang the Curies, si Rutherford, and also the Joliot Curies now further advance the field, now shaping the modern atomic and nuclear physics. So, kani sila nga mga significance of these discoveries extends across various fields. Now, it influences both the theoretical understanding and also the practical applications. So, I think that's it for our discussion for today, and I hope that you've learned a lot on our discussion. And we'll see you again on our next video. Thank you.